Ian is not here yet. Okay, I'm gonna get started anyway. So, because I think it's recording. Yes. Where's that blinking light? Huh? Oh, there it is. All right, so what I want to talk about is something that is going to take us away from BlueJ object bench. So one of the reasons why we use BlueJ is because it gives you these images of, which are shapes, and you create figures, and you use them as objects. And so let's take a look. Let's open up one of those projects, and I want you to understand what you've been doing on part 1 of object-oriented programming. So, pictures, yes.
Can I do class outside if I join from Blackboard?
Where are you going to be?
Just the Blackboard right down there.
Yes, you can.
Thank you.
You're welcome. So I think this is the one that we can create. One of these ones over here. And is this the one with the house? Let's take a look. Let's make it visible or draw it. Yes, this is the house. So the idea behind what you have done so far with these images is that you treated these individual boxes over here as if they were objects. And so to actually make it, to actually see it, you have to draw it. You can look at these methods, as they call it, in which you can change different colors, right? Let's see what happens. Here you have a method that changes it black. Then you use another method that sets the color. So we use methods to make changes to this object. Let me open up another one. Another project, which was the one before. I think it was figures. So I could create an object of person, and let's call it Bob. And it will go in the, take a look once again, in the object bench right here. If I want to see Bob, I have to make it visible. And there's Bob. And if you want to make changes to this object, I have to use all these things over here. I don't go to, let's see, if we look at the program itself, we know that there are these instance variables or instance fields. I like to call it instance fields. You're going to hear me saying instance fields most of the time. I recognize these are instance fields because it has this access specifier as private. So all of these are instance fields, meaning they can only be accessed through the methods. This is private and not public. If it was public, I can create a client class that will access that. A client class is another program that will be using the instance fields of person. Since it's private, you won't be allowed to do anything with it. Anything you want to do to this person, you will have to use the methods. Make it visible, move it. So you don't have direct access to the instance fields of this person, which is the height, the width, the position, in X and Y, the color, and if it's visible or not. I hope you understand what that means because that's the essence of what we call encapsulation. Encapsulation is a concept, and the concept is that data should be protected. How do you protect data? Well, the way best to protect data is to make it accessible only within the class itself. And so if you had to change anything about the data itself, you will have methods that will handle that. My typical example is the following. And I hope you remember this example because I will be using it a lot. So you have a friend coming to your house, right? And your friend is thirsty. So what do you tell your friend? go help yourself from the refrigerator. When you know that maybe there are things in there that, you know, your dad, your mom, your sibling has a specific drinks. I know in my house, the family has, well, I like this drink, I like that drink, and they all have these different things. So wouldn't you run into a possible conflict here in which that particular drink was used by your friend, when you know that the rule of the house is that don't touch that? So encapsulation will tell me, don't send your friend to get the drink. It will tell me, go get a drink that you know that can be given to your friend. So that's encapsulation. You take care of what belongs to you because you know how to handle it. You know that it will not run into any conflict with the rest of the family. And also, you can ask your friend, are you allergic to something? Is there anything that you shouldn't be drinking? So here we have an interaction with members of this class, in this case, methods, that know how to handle both sides of the parties, right? Both parties. The one who's asking for something, and then the class itself that is giving something. So that's the idea behind encapsulation. And you will have an activity with that. Now, we use BlueJ mostly because we can see this. I cannot make changes to this person unless I use the methods that are over here. If we wanted to make changes that are not part of these methods, what would you do? Let's say you want a method that jumps. Let's say you want the person to jump up and down. What would you do? Somebody give me an idea. Phil, what would you do? If you wanted to make this person, Bob, to jump up and down, what would you do?
Maybe the would move up method.
Yes, I think I heard that. Build a new method, did you say?
Yeah.
Yes. So you will need to build a new method, write a new method. So that means that you will create another member of this class that will handle the behavior of the person, okay, of Bob. So the idea behind using BlueJ is strictly for that, is to see that you cannot manipulate the actual instance fields directly. You have to use the methods. Methods are also the behaviors. Now, I told you many times that BlueJ is not really a developmental tool. It's mostly an educational tool. So we're going to close this a little bit. Actually, let me get out of here. So what you see over here, which is the object bench, is only used for the first part of object-oriented programming. Now we're going to do something that is not used in the object bench. That means that we're going to need, it doesn't matter. That means that we're going to need another program to actually create an object and to execute it. And this is where we go to the class anatomy. So I want everybody to go to this section. If you're doing something else, please stop and pay attention. So here you're going to see a whole bunch of concepts that you already watch and listen to. I'm going to be summarizing a lot of this stuff. Here we have an object. Here we have a list of objects. Here's what we call attributes and states. And if you recognize these values over here, they look pretty much like instance fields. And it is. A rectangle has an X and Y position in the plane, and you have a width and a height. What can you do with a rectangle? Well, first of all, we have to create it because that's the way it is in Java. You have to create it. And then we can move it around. And that's what we have a method called translate. Let's look at the gas over here. I'm sorry, car over here. An object of the class car, and if you go down here, this is the class, and these are the objects. So a car comes from the class car. I created an object called a car. And what would be the attributes of this particular class? Well, we can look at the mileage of a car, the model. The gas tank might give you information about how much gas you have in the tank. And what are the behaviors? What are the things that you will use to do something with the car, right? If I was going to ask you to write a small program that shows the minimal information in terms of what it can do with the car, you might want to say, well, add gas, use gas when you press the gas pedal. So these will be behaviors or methods. These are attributes and states. One thing that I had to mention that the author mentioned it is about something called states. And the states refer to something like, let's say an instant field is a Boolean, right? For example, we can say that a car could have an instant field called gas empty or tank empty. So that will be true or false. So then you will say, what's the state of the gas tank? It will be empty or not empty. So you have that Boolean that will be true or false, depending how you use it. And that will give you the state of the object. And that's why we refer to states, things that mostly have two possible outcomes. Think about a door. A door could be open or closed. So think about that. So, and it's also an attribute. It's just that it's a kind of specific attribute. I'm not going to repeat what it was said already. So I'm going to move on to looking at a graded class. And that's what you're going to be writing today. You're going to be writing a couple of classes. The first one is the graded class. The graded class has constructor. Constructor has the same name as the class. It doesn't have return type. Pay attention. A method does have return type, but a constructor doesn't. And again, it has to have the same name as the class, and it could or might not have an argument. In this case, the argument is information that is passed to the instance field. And if I was going to look at the class itself, it starts over here and it goes all the way down here, I can see that the instance field is this one because it says private. So the only instance field for the class greeter is name. So when I start, when I create an object of greeter, whatever that is, I'm going to have to pass information to the constructor, and that will be a name. And the name will be of type string. Then once it's there, this becomes like a global data that is accessible anywhere inside the class. I don't like to use the word global technically. Global in terms of the way we express the fact that the scope of the variable is everywhere in the actual class. When you have a local variable like this one, take a look. This one was created, message was created inside the method, then this is a local variable. And when this method finishes running, message goes away. It doesn't exist. But name will still remain for as long as the object is still running, executing. Now pay attention that I'm going to put a message over here. This is hello. And I'm going to use the instance field that it was declared over here and initialize in the constructor. And then we are actually creating a string with it by using the concatenation operator. So here's my class. Here's the class. Let's take a look at where I have the code for that. Okay, so what I want you to do is this. I want you to go to, hey, where is the, didn't put the link to it. No. Oh, here it is. Go to the website right here, everybody. scroll down. You should be working with me. I'm going to open my Blue Jay again and create a new project. Create a new project in unit 4. And we're going to call it object-oriented programming exercises. I'm going to oops. And let's look for that unit 4. Try to be organized. I see many of you don't like to be organized, but we're going to try it anyways, right here. There we go. Let me put this down. Is everybody working with me? Anybody wants me to slow down? Okay, you created a project, and now we're going to create a class. So I'm going to come over here. I'm going to take this right here. I want this to be turning by the end of the period, by the way. New class. I'm going to give it any name. It doesn't matter what I call it because I'm going to show you that we can change that. Open it up. Select everything and paste the new one. For me to change, you already changed the name. Save it. We can compile it. And you should have a nice looking box over here that it compiled successfully. If it didn't, you have to let me know. So this is the same, this is the object. This is the class greeter over here. You see the similarity between the two of them? Although it's missing the constructor, right? So let's create the constructor. So let's go over here. And we're going to say public, no return type, because it's a constructor, greeter. And as you can see in the lesson, we take in an argument. The argument is going to be a string, a name. And then I need those curly braces. And who can tell me how I can assign this? How I can assign, oh wait, we're missing something. What are we missing? Let's take a look. No volunteers? What is this class missing? Let's take a look. Julia, Julia, what is this class missing over here? If I'm looking at, maybe this one has a better view, right? Here. We are trying to write this class just the way it is. But it's missing two things. I'm building the constructor, and when I start putting the constructor together, I notice that I'm missing something. What is it? Yes, the instance field. The instance field is right here. Take a look. It has a nice arrow pointing at it. So we're going to say private. It's a string name. Again, here, all we did over here is we only declare the instance field. It has no initial value. We're going to give it an initial value over here. How do I do that? Somebody give me an idea how to do that. Give me an idea how to do that. Yeah, I can understand. Sorry that I didn't. Sorry about the interruption. We're back. So, anybody going to offer the information asking, or should I have to call in somebody?
You'd write name is equal to a name.
Very nice. Very good. So we're going to say name. That's the instance field. Is going to get from the argument a name, the data that we're looking for, a name. And of course, it's a semicolon. And we can compile, make sure that we don't make any mistakes. Obviously, we don't. And now we're not going to create an object as this. We're not doing this ever. We're done with that. Oh, let's say Bob. We're not doing that. If you go over here, look what it says. Do not do this. All right, remove. We're going to create a test class. Here's what it's called, a testing class. So the testing class is going to be called graded test. So let's do that. Let's create a new class. Blah, 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 I don't care. Actually, no. Yeah. And let me go to, where was that thing that we had? Right here, right? And now we can get it from here. So we don't have to spend time typing, and we can go straight to the concept itself. I open this up. And there you go. We having an error over here already. Anybody knows why?
Yes, sir.
Yeah. This one? Look, it's right. Ian, it's right here. Take a look. Click on that right here. Do you see it? Click on that, and that will give you the website. So let's go back up. And somebody had to tell me, I know many of you can tell me why there's an error over here. And actually take a look what it says over there. Cannot be applied given types, blah, blah, blah. What does it say over here? Jonathan, what does it say over here?
There's no arguments.
Right, so what's missing? Look.
Need a, like,
Can you see the arrow?
Put world.
Yes, we can put something else. So let's put something else. Let's put what is it going to say? Say hello world. Yeah, let's put world. That's very creative, right? But there is a reason why we're going to do that. And now the error went away. And that's because the constructor is asking for an argument. If we have an empty constructor, it's also called a null constructor, we wouldn't have that error. Okay, we should compile it without any problems. Let's take a look at the, hello, yes. Now, I want you to pull this to the side, bring the project right here. Right click on this you have done before, never with two classes together and just running this. There is no input argument, so we don't need to say anything. We can just press OK over here, and there it is. Hello world. So what I want you to do is the following. I want you to take a screenshot of this. Come over here like this. I want a screenshot, and that's what you're going to be submitting. Yeah, that's correct. So we learned to create. This is another reason why I like BlueJ, because it gives you these connections between the class that you define what the object looks like. This is the blueprint. This is the type, the category that the author talks about. You can call it also the factory, because you can create multiple classes, multiple objects of the same class. And for that, we're going to do that. So let's open let's go back to the test class. Now let's create another. Let's copy these 2 lines, bring it down, and let's give it a different name. Let's call it Dave over here. Dave greeter. And I'm going to put over here Dave. Now I can compile it. Wanted to run it. And look, I always click on main, right? Where did it go?
Miss Elliott,
Oh.
did you change? Yeah.
I forgot to change this, right? Yes, very good. Thank you. Let's change this to, very good. Who said that, Phil? Right. Yes. This sayHello method, right, is associated with this object. This sayHello method is associated with the world greeter. Take a look at how I qualified the method with whatever is in front of it and the dot, the period. Didn't compile. Okay, let's try this again. Must be behind it. Yeah. So let me redo this. Is that something is not right? Oh, yes. Oh, let's fix this. Let's fix this. Let's go over here. Here, this is what we're missing. All right, everybody fix this. Because right now, the method is pretty much static. It's going to always display the same thing. We want to use the argument, name. Name is accessible anywhere in the class. So we have to come over here and we have to make this change. So let's go over here. Da-da-da-da. I'm going to put the comma, space, so it's not one on top of the other one, plus, and now we're going to use the name. Name, like I said before, instance fields are accessible anywhere in the class. If I put a name over here, what do you think is going to happen? Let's see what happens if I do that. Ooh, it doesn't like it. It doesn't find it because a name is only accessible inside this block of statements. The scope is local. The scope of name is everywhere in the class. So if I change this to just name, it knows where it is because this is an instance field, meaning this is the data that belongs to any object of this class. Compile it, and now we should be able to get the right output. Compile this one also, and then we can go to main, click on that, okay, and there we go. We have hello world for the first, with this group of statements in which we create an object of greeter with the argument of world. And then we have another greeter object called Dave greeter, but the argument now is Dave. So from now on, once you finish part 1, you're going to do everything the way I just did. I'm going to have a class. It's also called an ADT. Anybody knows what ADT stands for? Eugene, do you know what ADT stands for?
Abstract data type.
Yes. So we're going to say that, and I want to put this comment, I want you to put this comment in greeter. It's a class, and it is also called ADT. And just like Eugene said, this is abstract data type. And this is my opportunity to talk about abstractions. What's an abstraction? Who can give me an example of an abstraction?
Standard draw is an abstraction.
A standard draw is an abstraction. Why is it an abstraction? What does he make it an abstraction, Nicholas?
It's an abstraction because it's kind of like a wrapper for the default draw methods that come with Java, and instead it gives us easier to use standard draw methods that
Very good.
access those lower level methods.
Correct. So a standard draw is easy to use. And he said something about wrapper class is because it's actually kind of creating this layer of abstraction that hides all the tiny components and tiny technical parts that are difficult to manage. So anything that does that is what we call an abstraction. When I look at the class over here, car, right? I'm only looking at adding the gas and using the gas. So this is also an abstraction. I kind of get rid of anything that I'm not interested in. I only focus on two specific things. So I create an abstraction. Many of you are driving, and some of you are maybe right next to the driver. And what does the driver know about the car to be able to go somewhere? Heidi, what does the driver know about the car when he's driving?
It knows things like the mileage.
Okay, what else? But to drive the car, do you really need to know the mileage?
No.
What do you need? What are the things that you need when you sit in the car, you start the engine? So what do you need now? What do you do next?
You should know how much gas is in the tank.
Yes, very good. What else?
You should know how to drive it.
Okay, and that means what? Knowing where things are. What things do you need to know where they are?
Like the gas pedal and the brake pedal.
That's it. There we go. So you as a driver, you have a limited access to the knowledge of what's behind all this big engine over here, right? The car. You care only about that it has gas, where the gas pedal is, where the brake pedal is, the steering wheel, and if it's automatic transmission, that's pretty much all you need to know. Of course, there are a lot of other details. So we eliminated all those details so we don't get too much information that will be difficult to manage, and we only concentrate to those things. As you get better at driving, maybe you know how to change the music, how to put the air conditioning while you're driving, things like that. So these are all abstractions. And we do that constantly in everything because we only like to focus on very specific things. So here is the way things are going to be done from now on. We are not going to create objects in the object bench because this is the way it happens in real life. And we learn from using those images before, those graphics, that you couldn't do anything to the objects unless you wrote methods to handle the instance fields. And that is the big concept of encapsulation. So let's scroll down a little bit more. I don't want to talk about the same things that you already talked, that the author already talked in the video, but I like to go to one more class together, although it's in the bank account, right? So, so what I want you to do is the following. So you're going to submit two images, two screenshots. So go to the greeted test because I want to see that you have two objects of the class greeter. And so take a screenshot of this, like this, right? This. And then you're going to submit these two screenshots. Any questions so far?
Miss Elia, we just have to submit that first screenshot that you showed us, right?
The two screenshots, one with chess hello world and the other one hello Dave. The two of them,
Oh, okay.
okay? Two screenshots. So I wanted to do one more, which is the bank account, because the bank account is one of the most popular classes in programming, learning programming, I should say. So the code is already written for you. So let's go to the website right here. Scroll down. Oh, it's the same website. So let me. And where's the bank account? Here's the bank account. As you can see, it's a little bit bigger. The grid is pretty much like a baby step onto this. So let's put a little bit more substance to this. So I'm going to copy from here all the way down to here. Let's go to the same project. We're going to create a new class. Doesn't matter what I call it. I'm going to put it somewhere else so they don't overlap. And I'm going to paste over here what I just copied. They should be able to compile without any problems. And wait a few minutes for you guys to do what I just did, because I'm going to ask you to take a screenshot soon. And this is part of class participation, so I will be grading you based on accuracy, also the timing in which you turn this in. So of course, we have, this is the ADT, the abstract data type. And to be able to execute the methods on this class, we're going to need a test class or a driver class. I like to call driver, but you're going to see a lot of word tester in there. College Board likes to use that, so we're going to stick with that. So copy this. This is another, this is a tester class. I'm going to come over here, blah, 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 whatever it is. Click OK. Hold on, let me bring this down. It's in my way. And I'm going to paste onto it what I just did. Should be able to compile without any problems. And you can see also how the two of them are related. What this says is that the bank account tester uses object of bank account. The greeted test uses object of the class greeter. So far, so good? Excellent. No questions? All right, so what do we do next? Let's go back to here. This is where the instructions are. So let's first look at the bank account. What does it look like? And let's see, I think we're going to have to put some comments in here. Some of them are already there. So here's my instance field. So we can put a comment over here. Instance field. And we can say only one right now. Let me separate a little bit from here. Here's what they call the constructor. It is the constructor because, Brendan, how do I know that this is the constructor? What are the things that I'm looking for in a constructor that is different from a method like this one, let's say?
Like what's different?
No, how do you, yes, but what, how do you identify that this is in fact a constructor? What is special about a constructor?
You don't have like the void in front of it.
Very good, no return type, and what else?
And it's the same name. Actually,
Yes,
yeah.
yes. The constructor has the same name as the class name. So here is a constructor in which the balance was set to 0. But then we have another constructor. Take a look. This class has two constructors. So I want you to add one more line over here of comment. And we're going to say that this constructor is an overloaded constructor. That's the word, the technical word for having more than one constructor. And the requirement for overloading is that they have different arguments or different number of arguments. Make sure you have that in there, because this is another concept. I don't remember if the author talked about that yet. So we can create an object of bank account without any balance. You start with a balance of 0. Or you can open an account with an initial balance. You can also deposit more money. So this abstraction allows you to deposit money, to withdraw money, and then we can get that information. You know, many times if you or your parents you've seen your parents go into the ATM machine and they want to know what the balance is, but sometimes it comes automatically. You might want to get that information separately. And so for me to get information about the balance, I need to create a method. And you remember on one of the questions that you had before, what do we refer to a get method? What kind of method is that? Shoshi? Nicholas raised his hand. Go for it, Nicholas.
It's a method that takes, because the method is within the class, so it has access to the private variables, and then it returns that variable so that something outside of the class can also access
Very
it.
good. We call that accessor method, and also we call it a getter method. Very good. So this doesn't change the instance field, but these two changes the instance field. Shoshi, where are you, Shoshi?
I'm in the tent
Okay.
on the
So,
lawn.
question. If this is an accessor method, because it doesn't change anything in the instance field, but this one does. Take a look, balance changes. What is the name that we give to methods that change the instance field?
I don't remember.
That's with the letter M. Anybody raising hand to help Shoshi? U T. Oh, no, Nicholas, somebody else. Nima?
I'm not sure. I'm looking. I was trying to remember.
Is it mutator?
Yes, it is. Very good. Mutator or setter method. Obviously, deposit doesn't have the word set, like get in balance. And so that's going to happen a lot, that a mutator method might not have the word set, but we still know that it's changing the instance field, so it is a mutator method. Okay, who can tell me if this is an accessor or mutator method? Jessica, is this an accessor or mutator method?
Mutator.
Yes, it is a mutator because it changes. And again, it doesn't have the word set, but it's okay because we can see that the word deposit is affecting the balance, and therefore withdrawal is coming to affect the balance, which is the only instance field in this class. Excellent, very good. Make sure you decompile this and decompile this too. And what's happening? Let's go to the tester class. What is happening over here? Here we create one object. Only Harry's check-in is the only object over here. Only one object of this class is created. And a lot of things happen here. Take a look. You deposit, first of all, what's the balance over here? Who can tell me Marwan, what's the balance of Harry's checking account? Marwan, are you there? Ian, what's the balance of Harry's checking account? Look at the constructor.
New bank account,
Yeah, so what do you think the balance is?
2,000.
Take a look. If I use the constructor, right? It has nothing in there. You see the constructor, look at the constructor over here. Doesn't have anything inside the parentheses, right? When we go to the class, what happens to the balance? How much is that?
0.
0, very good. Balance of Harry's account is 0. So, but Harry starts with 0 balance. He deposits $2,000, withdraws $500, and we expect that the balance was going to be 1,500. Let's run it. Let's go over here, compile it, and let's run it. Just with main, and there it is. Actually, let's do it again without any stuff from before because you're going to need to take a screenshot, and there it is. So what I want you to do is bring this over here, this over here, and take a screenshot. And that will be it for today in terms of me showing you something new. So 2 screenshots for the first one, 1 screenshot for this for classwork. And the first one was hello, Dave, right? So what I want you to do for homework or asynchronous work, whatever you want to call it, is take a look over here. Let me close this. This is what I want you to do. I want you to, we did this part. There's a little change over here. Make some changes to that, to whatever you already have. And now you're going to add a new method, a method that will have an impact on the instance field. This method doesn't return anything, that's why it says void, but it's going to add interest. So an argument has to be given to that method, the rate. So you're going to write that over there. That will be your task will be to write the body of the method. And they give you an example of how that method affects. So if we create this savings account, mom savings account, with the initial value of $1,000, when you add the interest of 10%, then when you print it, it's going to give me $1,100. There you go.
Miss Elia?
Yes.
So for the classwork, we have to turn in the 2 screenshots for the class anatomy, and then do we turn in this screenshot with the Harry's checking stuff for the 13.32?
Yes, that's correct. That will be classwork and participation grade. Correct.
And then we turn in this thing that you're just explaining also to the 13.3 bank account?
Correct. 100% correct. Anybody has any other questions?
I have a question.
Yeah. What's that? Right. Very good. So let's go over that again. What Heidi was just saying also was that for this one, you need 2 screen. Is this the first one? Yeah. For this one, you need 2 screenshots. One with hello world, the other one hello world and hello Dave. And then for the bank account, you need just 1 screenshot, the one we just took right here, in which we had this. I know I had something else right here. I think it was the tester class. There you go. Yes. And that will be perfect for class participation and classwork. Okay? All right. Wait, I cannot hear you. What's that? Right, right. So, right, in class, good question, Ian. In class, we just have screenshots. Now, outside class, asynchronously, you're gonna do the rest over here. And so you're gonna just submit the program. I think that would be the best idea. Make sure the output, for example, here, I will do this. I will come over here, like we have done so far all this time. And I will put this over here. So when you make those changes that you see over here, you have the option. The best is to do this, I think, my opinion. If you want to take a screenshot, it's fine. The important thing is that I should be able to see what I expect to see, right? So you can get a good grade.
Miss Alia?
Yeah.
So for 13.3, is it okay if we submit twice, like the classwork and
Yes.
then the asynchronous work?
Definitely, yes. You will submit twice, yes. Any more questions, anybody? All right. Cool. I have to.